Hello everyone, my name is Tejas Shah, and today I will show you how I made my custom macropad with a Raspberry Pi Pico. Last year I made a simple 2-key macropad with a Pi Pico, but since I switched my keyboard out, which had a knob, for one that doesn't, I wanted to make a new macropad that had a knob that I could use. For the knob, I initially was planning on using a potentiometer, but then I learned about rotary encoders, which is the part that is used in most keyboard knobs, including the one that I have. The feature that I really like about rotary encoders is how tactile it is, which makes you feel this really satisfying bump as you turn it. And I got mine off of Amazon in a pack of 5, and so far they've been holding up really well. As for the switches, I ended up using some spare Royal Clutch brown switches that came with the RK61. They aren't the best switches, but they are what I had on hand, and I really don't have the need for more than 4 switches. And finally, the microcontroller board that I used was the Raspberry Pi Pico, and using this board is overkill just for 4 switches and a rotary encoder, but like my RK switches, I didn't want to go out and buy a new microcontroller as I just had these lying around. With all of the parts selected, I started making a prototype on the breadboard, and instead of using the actual switches, I just used 2 push buttons just because they're easier to use on a breadboard. For the code, I used CircuitPython and the Adafruit HID library to map all of the buttons to the keyboard shortcuts. And the Adafruit HID library is super easy to use and allows you just to emulate any key press, which makes it super easy to create these custom commands. And as for the code, it's pretty basic. It just consists of initializing the GPIO pins and then having a few if checks just to see if the button has been pressed, and when pressed, it'll emulate the key press using the Adafruit library. And for now, I just set my buttons to be copy, paste, play, pause, and U-tab. And as for the rotary encoder, I just use the volume when turned and to mute and unmute when pressed. With a working prototype, I started to work on the final design, which started with a custom PCB. To design the PCB, I used a website called EasyEDA, and after some time, I had finished my design. This was the first time that I've designed a PCB from scratch, and it was actually a lot easier than I anticipated, but maybe that's because my design wasn't too complex. There are definitely some places that I could improve in this, but overall, it was a pretty good first experience. Once my PCBs arrived, I started to solder the components on, and I initially only just put a rotary encoder, a single switch, and the Pico on just to test to see if they worked, and thankfully the PCB worked. And then once that was working, I started to solder the rest of the components on, and at the end of it, I had an assembled macropad. The last thing to do was design a case for the macropad. I used a website called Onshape to design the case, and 3D printed my design on my Ender 3. I opted for a snap fit design as I didn't really want to use screws or adhesives to secure the product because I want to take it apart pretty quickly. I'll admit my CAD skills aren't the best, so it took some time and a lot of iterations to get it right, but I did eventually get it. And this is the final product. I think it turned out really well. I'm really happy with it. I've been using it for a couple of months now, and it has been doing really well, especially the volume. The print could be a little bit better. As you can see, there are some gaps, but I don't mind too much. I'm just happy that it works and that I've learned a lot in the process as well. Alright, thank you for watching. Hope you have a great day, and see you later.